Today we're looking at notes 5-6, solve quadratics using graphs and tables. For the following quadratics, graph, then state the x-intercepts, or in other words, solutions, zeros, or roots. So if I ask you to solve a quadratic, essentially that means find the x-intercepts if you're thinking graphically. Or I could say find the zeros or find the roots, and essentially that still means find the x-intercepts graphically. So we're going to start on number 1 by graphing this quadratic that has been shifted right 3, down 1. So I'm going to go right 1, 2, 3, down 1. I'm going to plot my new origin. From there, because I have no vertical or horizontal stretch, shrink, or reflect, I'm going to plot my original x and y values for the quadratic graph. So left 2 up 1, 2, 3, 4. Left 1 up 1, 0, 0. Right 1 up 1, right 2 up 4. So I can clearly see on this graph that my x-intercepts are the coordinates 2, 0, as well as 4, 0. So those are my solutions, roots, zeros, x-intercepts, whatever you want to call them. Okay, so notice, of course, all of my x-intercepts are going to have a y value of 0. That will come in handy soon. So here on number 2, I have a graph that's been shifted left 4. So 1, 2, 3, 4. There's my new origin. You should know that that negative means the graph reflects over the x-axis. If you need to, you would multiply the y values by -1, or in other words, negative y. But some of us can do this in our heads, so you don't need to draw the table. So you should know that you're going to go left 2, down 4, left 1, down 1, 0, 0, 1, -1, and 2, -4. And again, if you need to do the table to see that, then go ahead and do so. So here's my graph. My vertex sits on the x-axis. I don't cross through the x-axis. I just kind of sit on it. So that is still considered an x-intercept. We say that that is at the coordinate -4, 0. So as you can already see, sometimes your quadratic will have 2 x-intercepts, sometimes it'll only have 1. All right, let's look at number 3. This graph has been shifted right 5, up 1. So right 1, 2, 3, 4, 5, up 1. There's my new origin. I have a vertical stretch by 2. I would multiply my y values by 2. Again, some of you will need to show that on the table. Some of you can do it in your head. So you will go left 2 instead of up 4. You will go up 8 because you're doubling it. Okay, and instead of going left 1 up 1, you'll go left 1 up 2 because, again, you're doubling. So then we have our quadratic graph. So you can see on this graph that we are not going to cross or sit on the x-axis. This graph does not have any x-intercepts. So we don't say no solution, we say no real solutions. So yes, in the near future, we're going to be talking about non-real solutions, imaginary solutions. So this, for now, you will say no real solutions. Not no solutions, but no real solutions. Okay, last graph here. Left 6, down 9. 1, 2, 3, 4, 5, 6, down 9. There's my new origin. I'll plot my original points because I have no vertical, horizontal, stretch, shrink, reflect. So left 2 up 1, 2, 3, 4. Left 1 up 1, 0, 0, 1, 1, and 2, 4. Well, obviously I am going to cut through the x-axis, but where? So remember, we've talked about this before. If you need to add coordinates, then you can add -3 here, and you can add +3 here. And how did I get these y values? Well, by taking the x values, plugging them into the parent function, and so in other words, squaring these values. So -3 squared is 9, as well as +3 squared is 9. So I would go left 1, 2, 3, up 9, and right 3, up 9. So that gives me my 2 x-intercepts here. So my x-intercepts for this graph would be -9, 0, as well as -3, 0. Okay, so that's looking at the graph by hand. Now in 5, 6, and 7, we are going to look at the graphs in the calculator and make the calculator give us the solution, zeros, roots, x-intercepts. Okay, so on number 5, I have already gone ahead and I've plugged it in to the equation, the quadratic equation, into the y equals of the calculator, x squared minus 2x minus 5. So you'll notice another big thing why you would want to use the calculator here is because this quadratic is in standard form while these were in vertex form. They were very easy to graph by hand. They were already in vertex form. This, on the other hand, would not be quite as easy to graph by hand because you'd have to get it in vertex form first, or just start plugging and chugging with coordinates and finding x values and y values, but that would not be fun. So we plug in the standard form quadratic equation into the y equals of the calculator. We take a peek at the graph. I've drawn a little sketch here, and what you're going to do is on the calc, you're going to press second calc 2. So second calc 2, that was 0, so I'll show you again. Second calc 2, we're finding the 0. Okay, and you'll notice I have 2 zeros on this graph. I have one here and I have one here, or in other words, I have one here and I have one here. I've got to find each of them one at a time. So you'll notice this says left bound question mark, and you see a cursor blinking. So I need to take that cursor and I need to move it to the left of my first x-intercept. So yeah, it's going up, but it's also going to the left. So my cursor is now currently to the left of this x-intercept, and I'm going to hit enter. Notice this little arrow thing came up. On the new calculators, it will create a dash or a line. It's a light line, but it will create a line on the left. And then it'll ask you for the right bound. So you'll go just to the right of this x-intercept. We're ignoring this x-intercept for now. So just go to the right of this x-intercept. That's probably good enough. Hit enter. And again, on the new calculators, you'll have lines. On the older calculators, you'll just have these little arrows. You need to kind of drag down your arrows and make sure, is your x-intercept within those arrows? And yes, it is. So then you hit enter because it's saying, do you want me to guess now? And you're going to say, yes, I do. Okay, so 0. My 0 is at negative 1.449. We're going to round to 3 decimal places. Comma 0. As we expected, the y value should be 0, just as it was for all of these. So my x-intercept is negative 1.449, comma 0. Of course, that's only the 1. Now we've got to do this process all over again. Oh, yay. So second calc 2. And then now we need to go to the left of this x-intercept. So about there, hit enter. Okay, and then to the right, hit enter. And then your 0 should lie between those 2 arrows. You hit enter again. Yes, I want you to guess. And my 0 is at 3.449, comma 0. So 3.449, comma 0. So those are my 2 x-intercepts. I'm glad we didn't find those by hand. What about you? Okay, so that was on number 5. Now let's look at number 6. Number 6 is in y equals 2x squared. So 2x squared minus 19x plus 45. And I'm going to graph. Okay, so it looks as if the vertex is lying on the x-axis. Can I be sure of that? No, I need to do a zoom to take a closer look. So zoom to, which means zoom in, and you should see a cursor blink lightly. It's right there if you don't see it at home blinking. I'm going to scroll it until I get about where that vertex is. That's where I want to zoom in. So then I'm going to hit enter. Oh yeah, much better look. It looks as if that vertex does not sit on the x-axis. It actually, the quadratic cuts through. So again, I want to do another zoom to get an even closer look. So zoom to again. The cursor's right there blinking. That's about where I want to zoom in. So I'm going to hit enter. Yes, this is a much better picture. So now I can see my 2 intersection points, and I'm going to do a second calc 2 again. Scroll that cursor to the left of the first x-intercept, hit enter. Scroll that cursor to the right of that x-intercept, hit enter. My 0 definitely lies between those two markings. I'm going to hit enter again. And it tells me my 0 is at 4.5, comma 0. So 4.5, comma 0. Let's do that process all over again. Second calc 2. I want to be to the left of this x-intercept here, hit enter. I want to be to the right of this x-intercept here, hit enter again. 5, comma 0. That's my other x-intercept. All right, so I'm going to type in number 7 in the y equals. But wait, I notice I have this equals negative 25. I need it to be something equals. All of the terms need to be on the either right or left side of the equal sign. So I'm going to move this minus 25 over and put it on the left with the other terms. So 4x squared minus 20x plus 25 equals 0. Okay, and that makes sense that we have equals 0 because we know our y value is going to be 0 for an x-intercept. So I'm going to plug in 4x squared minus 20x plus 25, hit graph. Oh no, my calculator is still zoomed in. I need to do a zoom 6 to return the graph to normal. Zoom 6. It's back to normal. I can see my quadratic. I'm going to have to do another zoom 2 to take a closer look. So zoom 2, find my cursor blinking at me, scroll to where I want to zoom in, hit enter, get a pretty good picture. That looks like that vertex lies on the x-axis, not that we cut through. Let's do another zoom 2 just to make sure. Zoom 2, make sure your cursor's where you want to zoom in, hit enter. Yeah, that vertex is on the x-axis. Let's do a second calc 2. Scroll our cursor to the left. Scroll our cursor to the right. Hit enter. And we get our 0 is at 2.49999. So that means it's, when we round, 2.5, comma 0. Okay, so that's just one x-intercept on number 7 because the vertex lies on the x-axis. So that's all we're going to do with graphs. Now we're going to talk about tables. So on the second page, each table shows ordered pairs that satisfy a particular quadratic function f. Based on the table, A, give the solutions or the intervals of the solutions to the equation f of x equals 0. Also state if the solution is a double if applicable. Okay, part B, give the vertex, supposed to say on the interval the vertex is found, or the interval the vertex is found. No, that's correct. Okay, is the vertex a max or a min? So part A, give the solutions. Well, you just saw via mini graphs that solutions of a quadratic all have one thing in common. They all have a y value of 0. So when I look at this table, this is x, this is f of x, so in other words y, I'm looking for that y value of 0. So here 2, 0 is one solution, and 6, 0 is one solution. Okay, but you look at your table in 8, and you probably see, oh wait, there's no 0 for y. But you can give the interval, so it says to either give the solution or solutions or the interval of the solution. So you know that this graph is going to cross through the x-axis when the y values either go from positive to negative or negative to positive. Because think about it, somewhere in between negative 17 and 1, what number falls in between there? 0 does. 0 falls somewhere in between there. Similarly, from positive 1 to negative 17, what y value lies in between there? 0 has to. If I'm going from negative to positive or positive to negative, 0 has to lie in between there. So when we state the interval, though, instead of using the y values, we use the x values. So my interval for the solutions would be somewhere between, x lies somewhere between, for both of these, x lies between -3 to 2. Just as you did with domain and range, you put the least to greatest, you put the less than signs, and we're describing the x values. So either from -3 to -2 or from 1 to 2. Not including, because we know those aren't our zeros. We know it's in between there. Okay, so let's look at number 10. On number 10, we get lucky. We have one of the solutions, 5, 0. That must be the only solution. We'll come back to that. Okay, on this table on 11, notice I don't have a switch from positive to negative or negative to positive. All of these y values are positive. That means this graph must be similar to this graph, that all of my y values are positive. There's no real solution. No real solutions. Okay, now let's talk about part B. Give the vertex or the interval the vertex is found. Well, the vertex should be an easy find as well. I'll use red because the vertex is the only point of its kind, meaning look at these y values. They match, they match, they match, they match. That's because, think about it, on the quadratic table, the vertex is the only one of its kind. All the other y values around it match. So that means whatever lies in the middle of the matching y values, that's your vertex. So my vertex is 4, -4. Now C goes hand in hand with B. So is the vertex a max or a min? Well, look at the vertex. Is this y value the lowest y value on the graph, or is it the highest? Well, it's certainly the lowest, so it is a min. Okay, so let's look here. Here, these y values match, these y values match, these y values match, these y values match. My vertex lies somewhere in here. I don't have the coordinate, but I know that it lies somewhere in between here. So again, I'm going to do that interval. So x lies between -1 and 0, right there. Here, notice y values match, y values match, y values match. This coordinate in between is my vertex. This makes sense. My vertex lies on the x-axis. Okay, that's why I only have one solution. So let's go back to, are these maxes or mins? Is that y value the lowest or the highest? Well, it's the lowest. All the other y values are higher, so this is the min. Are these y values here in the middle? Is this y value going to be the highest or the lowest? We'll look all around. All around, these y values are getting lower and lower and lower. So this vertex will be a max. Last but not least here, I have a similar situation to number 9. Okay, I don't have my exact vertex, but I know it's somewhere in between 0 and 1. It's somewhere in between here is my vertex. Look at the y values. What's happening to the y values as I go in either direction? They are getting bigger and bigger and bigger. So that means the vertex is a min here.